How we doing, guys? Looking at rates of change here. That's page 126, 127. If you've got text and test 5. We're going to do questions 5, 3, and 8. Question 5 asks us population of a new housing estate 2 years after a certain date is given by this formula here. Find the rate of change. Okay, anytime you see that rate of change, think dy dx. Okay, that's a really important word. You're going to see it an awful lot in this exercise. But in general, that's dy dx, or the derivative of the population after 3 years, and explain your answer. So here's our population function in terms of time, or population as a function of time. I've just multiplied out brackets there. It makes it a bit easier. Rate of change, so we know is dy dx, or the derivative, or p prime of t, or dp dt. Those are the same notation, just saying two different notations saying the same thing. And it's going to be 100 minus 50t. At t equals 3 years, the population, the rate of change of the population is going to be 100 minus 50 times 3. That's minus 50. Okay, what does that mean? Well, first of all, let's have a quick look at Geogebra. Here's our population function. Okay, you can see your maximum population there is after 2 years. We're up to 600 people. After 3 years, the slope of that tangent is going to be minus 50 that we've just worked out. What does that mean? It means that at 3 years, the population is declining at a rate of 50 people per year. Okay, so that's 50 people per year. And it says explain that. Well, there's your explanation. That minus 50 represents 50 people per year leaving this housing estate. Question 3 then says the area of a circle is given by pi r squared, which you know from junior cert. Find the rate of change of the area of the circle with respect to the radius at these 2 points when the radius is 5 and 10. So the rate of change is d something. Okay, rate of change of area, dA, with respect to the radius, dr. Okay, so there's our area function is written with r is the variable. So in terms of r, dA dr, or a prime of r, same thing, will be 2 pi r. Now, what does that mean? Well, actually, let's have a look at when when r is 5 centimeters, then we have a prime of 5 is 2 pi times 5. That's 10 pi, or 31.4 centimeters squared of area for every centimeter of radius. Okay, a prime at 10 is 2 pi times 10, that's 20 pi, and that's going to be 62.8 centimeters of area for every centimeter of radius. That is an increase of 62 centimeters squared for every area of radius. And graphically, what we're seeing in that question is this circle getting bigger as the radius increases each time by 1. The area increases according to a pi r squared, a quadratic formula. So you can see this point P, a radius of 0, area of 0, a radius of 1. That's the area of, what's that, about 4. Radius of 2 gets you an area of about 12, an area of 3. The radius of 3 gets an area of about 27. And it grows very quickly there. In fact, it grows according to this quadratic pattern here. I'll just compress that so you can keep an eye on it a bit better. And what we are seeing, or what we've worked out, is that the slope of the tangent at 5, okay, that's an area that's growing. There's the slope of the thing is 31.4. The area is growing at 31.4 centimeters of area for every extra centimeter that you increase the radius there. Whereas by the time you get to 10, an increase of 1 centimeter of the radius is going to cause a much steeper slope of 62.8 centimeters squared of area. And we'll finish on question 8. A body moves in straight lines, so the distance s meters traveled after t seconds is given by this cubic formula here. Find the speed of the body after 3 seconds. Find the acceleration of the body after 1 second. After how many seconds is the body momentarily at rest? So here's our function. It's a cubic. Our speed, well, speed is the rate of change of distance, okay, with respect to time. How fast you're traveling how far you're traveling each second is ds dt. So for us, speed function, at any time t, the speed is given by 3t squared minus 8t plus 4. So at 3 seconds, it's going to be 3 times 3 squared minus 8 times 3 plus 4. And that's what's that? 27 minus 24 plus 4, 7 meters per second. The next part says find the acceleration. So the acceleration is the rate of change of the speed. Okay, so here's the speed. Let's call that v. Okay, it's the rate of change of v. It is dv dt. Of course, that's just the second derivative of the distance, 6t minus 8. So at t equals 1, the acceleration at 1 second is going to be 6 times 1 minus 8. That's minus 2 meters per second. Now, what does that mean? Minus 2 meters per second means it means if it's traveling this way, it's accelerating in the opposite direction. It's slowing down at minus 2 meters per second. Or it may have even stopped traveling and it may have be moving in this direction. It might have velocity in that direction as well. But it's slowing down anyway at 1 second. The third part of the question then says, when is it momentarily at rest? Well, at rest means the velocity is 0. So that means this function here needs to equal 0. So that gives us this quadratic 3t squared minus 8t plus 4 has to equal 0. Now, a little note there, I'm going to ask you to check down in a second, but just give me space on the page. How do we solve that? Okay, so first of all, we're going to have 2 times when this thing's momentarily at rest. So 3t squared minus 8t plus 4 equals 0. You can use minus b, or you can say 3 by 4 is 12, and 6 by 2 minus 6 by minus 2 gives plus 12. So I'm going to say 3t squared minus 6t minus 2t plus 4 equals 0, and that's 3t times t minus 2 minus 2 times t minus 2. 3t minus 2 times t minus 2 equals 0. So that's 3t minus 2 is 0, 3t is 2, t is 2/3 of a second. It's momentarily at rest. Or t minus 2 equals 0, t equals 2. So there's 2 times there when it's momentarily at rest, either at 2/3 of a second or 2. And I'll just make that point. You take that note down. Okay, this comes up in a lot of these problems in this section and in papers as well. If s represents displacement or distance traveled, ds dt, the rate of change of that distance, is the velocity. If you call that v, then the rate of change of velocity is acceleration. That can also be thought of as the second derivative. Okay, I might ask you now to go and have a look at page 127 and do questions 6 and 7 yourself. See you in class.